This video is over topic 31, number 1. So there's some information here about how operations work, the order of operations, and then we're looking at linear versus exponential change, where essentially we're going up a level from that linear relationship where you have an initial value plus a change amount, that then the change amount is multiplied by the number of repetitions because we shortcut repeated addition with multiplication. Then we have what's called exponential relation, where we have an initial value that gets multiplied by something. So it has a change factor. You multiply by that repeatedly, and repeated multiplication is shortcutted by a power. So the number of times that change happens is represented by an exponent applied to the change factor. So this gives us our exponential function that we see on the formula sheet here. So C is the initial value. B is the change factor. And X is how many times the change happens. So in this first example, we're looking at some quantities that are changing over time. Both of these represent two accounts that start at $8,000 at time 0 and then shows their balances at different times. They both go to 8,400 at time 1. Let's assume that's years. But then they start changing and not being the same. So we're going to calculate absolute change from year to year on each of these, relative change from year to year, and the change factor from year to year. So absolute change, subtract. So 8,400 minus 8,000, 8,800 minus 8,400, 9,200 minus 8,800, 9,600 minus 9,200. So you can see we're counting by 400 in the money here. As we're counting 1 year at a time, each year it's adding $400 onto that account value. For the relative change, we're looking at that 400 compared to the previous year each time. So for the first year, 400 divided by 8,000. For the second year, 400 divided by 8,400. Then 400 divided by 8,800, 400 divided by 9,200. You can see we get exactly 5% the first year. Second year, it's 4.76%, then 4.55%, and then 4.35%. So that same $400 is being compared to a larger and larger amount, so it is becoming relatively smaller and less significant. For the factor, I'm going to divide the value by the previous value. So just like I subtracted, now I'm dividing 84 divided by 8,000, 8,800 divided by 8,400, 9,200 divided by 8,800, 9,600 divided by 9,200. And so we get 1.05, 1.0476, 1.0455, 1.0435. Be thinking about what relationship is happening between these two columns. Then for the second account, for account B, if we look at the absolute, we're subtracting 8,400 minus 8,000. Of course, it's still 400, but then we go 8,820 minus 8,400, 9,261 minus 8,820, and 9,724 minus 9,261. So this is still added 400 the first year, but then added 420, 441, 463. So we're adding a larger amount each year. For the relative change, I'm taking each of those absolute changes divided by the previous value. So 400 divided by 8,000, 420 divided by 8,400, 441 divided by 8,820, 463 divided by 9,261. And you're seeing those first three all came out exactly 5%. And then the third one, certainly we would have to go out 4.999. We'd have to go nearest thousandth of a percent, and we're going hundredth of a percent. So 4.99, and then it's going to round up. So this ends up rounding to 5% as well. Then for the factors, dividing each year by the previous year, 8,400 divided by 8,000, 8,820 divided by 8,400, 9,261 divided by 8,820, and 9,724 divided by 9,261. Again, the first three came up exactly 1.05. And then this one would round to 1.05. Even if you're going out to 4 decimal places, it still rounds to 1.05. All right, so the linear change is we are adding the same thing each year. That would be function A. The amount being added each year is the 400, the change in the function value for a 1 unit change in the input t. So that means $400 is added each year. The linear equation, we have the initial value of 8,000. And then adding, so the plus 400 multiplied by however many years. The exponential change is where we have the same change factor. So that would be B has the same factor. The change factor is the 1.05. So each year, the previous balance is multiplied by 1.05 each year. The exponential equation, b of t, we're going to have the initial value, 8,000, times, you can do the dot, just be real careful that you know that that's not a decimal point. So I prefer to do an asterisk, or you can put parentheses, 1.05 to the t power. Make sure also you're writing that t power, so it's not just a t after the 1.05. It has to be in that exponent position. Then the constant relative change we saw also in B had the same 5%. Relative change 5%. That means the account was increasing by 5% each year. So that 5%, not of the 8,000 each year, but 5% of the previous year each year. So we have this repeated percent change. And if you look at the relative change, that percent increase, 5% versus the change factor 1.05. If you remember with percent change, sometimes you had to take 100 plus the percent change. That would be 105%. 1.05 is the decimal form of that. You can see that with these other relative change versus the factor, that it is the decimal form of the percent change added to 1 in all those cases.